This second video in our Getting Results with RUSLE2 playlist recommends some things to think about before starting up your RUSLE2 software. A first general recommendation for getting the most out of RUSLE2 is to use the software like a planner, not a robot. What do we mean by that? It can be easy to fall into the trap of jumping right into the software and then robotically entering data for every field and scenario without too much strategic thinking up front. Instead of doing that, consider some of the following suggestions. Some of these are relatively advanced ideas and maybe don't matter if your RUSLE2 project is small, but the bigger your project, the more useful this advice is likely to be. And after we go over the concepts on this slide, we'll illustrate them with a practical example. First, remember the overarching goal, which is to draw appropriate conclusions based on RUSLE2 results. It's not necessarily to model exactly what the farmer is doing on every field. Next, try to keep in mind the purpose of your RUSLE2 project before you get started. If you want to be more efficient with RUSLE2, what you will learn is it's often best to use different strategies depending on your purpose. Try to keep in mind underlying technical principles. For example, if you understand and can think about how T factors, K factors, LS, and other factors will impact your outcomes, it can really help you in selecting your inputs for most efficient use of RUSLE2. And then finally, recognize that there will be judgment calls in your input selection. For example, one common dilemma you'll face is whether to lump or to split. If you have a field with variable topography, should you represent that with one LS input or multiple LS inputs? So here's a practical example illustrating how to apply some of the advice we've just given you about thinking things through before you fire up the software. In this example, our purpose is to verify that sheet and rill erosion, soil loss, doesn't exceed soil loss tolerance, or T, on many dozens of fields across 11 tracts. Those fields could be managed by a single farmer or by multiple farmers, that doesn't really matter. So a robotic strategy for tackling this project is simply to do RUSLE runs for every field and management scenario on those fields. Just run them all, dozens of RUSLE2 calculations. A more efficient strategy might look like this. Compile and compare inputs for all the fields before you start RUSLE2. And then in RUSLE2, start by modeling only the worst case scenario or scenarios. If the worst case fields and scenarios meet T, then we can safely conclude that all of the other fields will meet T as well. This table gives you an idea of how this process might look. We've got 11 tracts with multiple fields in each tract. So we're going to start by compiling in a spreadsheet key RUSLE2 attributes for each field. And as shown here in this first row, those RUSLE2 attributes include soil loss tolerance, or T, our erodibility factor, or K factor, for the predominant soil type in each field. And then we also have our topography inputs, percent slope, and slope length. Once we have that together, we triage and pick the worst case fields from each of our 11 tracts, and that's what's shown here. We have 11 fields identified, and these are our worst case for each of the 11 tracts. Then we triage some more and pick the worst case field overall, and that's this one here. It has the highest K factor by a long way, and it has the steepest slope. Next, we'll identify the farmer management under consideration that has the highest erosion risk, right? The most tillage, the least cover, and so forth. And after all that triage, we start by modeling in RUSLE2 just one scenario, right? Which is the worst case farmer management on the worst case field. And if we're lucky, that worst case combination will still meet T. And as stated before, if that's true, then we can safely conclude that all of the other fields and scenarios will meet T as well. It's not always going to be that simple, but this illustrates the general approach to using RUSLE2 more strategically when you have a very large number of fields to model. Here's another thing to think about before starting up RUSLE2, and this advice applies to all RUSLE2 users, both beginner and advanced, working on any side project from small to large. Quality RUSLE2 inputs are the key to efficiently producing quality RUSLE2 outputs. Therefore, we recommend that you compile and organize your input data first before you start your calculation in RUSLE2. And this includes understanding the details of the farmer's management, and it includes finding and building the RUSLE2 files you're going to need to model that farmer management in the software. So again, do your homework and get your input data organized before you start, and we're actually going to illustrate that process in the next video. So that concludes this video. Up next is an introduction to the RUSLE2 calculation that we'll be demonstrating and the inputs we'll be using in that calculation.